Okay, for the last section, we're just going to do lots of examples. We'll do examples of simple inequalities. Those are ones where they just have one inequality sign. And we will do examples of compound inequalities, and that's where there are two inequality signs. So solve and graph. So our steps are going to be exactly the same. The first thing we want to do is clear parentheses. So for this one, my 3 would stay the same. And then I'll distribute that -4 to the h, and I'll distribute the -4 to the -2. So I'll have 3 minus 4h, and then the -4 times -2 would give me +8, and then my right-hand side stays the same, -5h plus 6. First step is to clear parentheses, and I did that. My next step is to combine like terms. So on the left-hand side, I have two like terms. The 3 and the 8 can be combined. So I get -4h plus 11 is greater than -5h plus 6. Okay, now I want variables to one side, constants to the other. So if I subtract 11 from both sides, I get -4h is greater than -5h minus 5. Notice I did not change the direction of the inequality. With addition and subtraction, it doesn't change. It only changes as if you multiply or divide by a negative number. Okay, now I add 5h to both sides. So -4h plus 5h just leaves me with h and -5 on the other side, so I'm done. H is greater than -5. I was asked to express this answer by graphing it. So on the number line at -5, I'll either put an open circle or a round parenthesis. So if we do an open circle, and I want h greater than -5, so I shade all the numbers greater than -5. And that is the first example of doing a simple inequality. Okay, solve this guy and write it in interval notation. Now I want you to pause the video and do this one on your own. Okay, now that you're done, first thing we want to do is clear parentheses. So on the left-hand side, we need to be careful. I know it's easy to do, but it's also easy to make a mistake. When you distribute that negative, it has to go all the way through. So it's 8 minus 2x, and then minus a -5 would be plus 5. There will be a lot of people that leave that 5 as a -5, so be careful there. Now, it started out having a fraction, but you notice that fraction went away pretty quickly. 1/3 times 9x just gives me 3x, and 1/3 times -6 just gave me -2, so I'm not going to have to deal with fractions after all. Okay, now I want to combine like terms. So I have -2x plus 13 is greater than or equal to 3x minus 2. I want variables on one side, numbers on the other. So I can subtract 13 from both sides. I get -2x is greater than or equal to 3x minus 15. Subtract 3x from both sides, and I get -5x is greater than or equal to -15. Divide by -5. Now when I divide by -5, is that going to change the inequality? Yes, it will, because multiplying or dividing by a negative changes the inequality. Notice it didn't change when I was subtracting, only if I multiply or divide by a negative. So that will give me x is less than or equal to, I flip that inequality, 3. Now I need to write my answer in interval notation. If it helps to just do the graph first so that you can see which way the interval notation goes, you can. But if x is less than or equal to 3, that means I'm going to go all the way down to -infinity. So it's -infinity up to 3, round parenthesis on infinity because infinities always get round parentheses, closed bracket on 3 because it's less than or equal to 3. Okay, those are two examples of simple inequalities. So we solve those exactly the same way that we solve equations. The only difference is that if you multiply or divide by a negative number, you have to flip the direction of the inequality. Okay, our next examples will be compound inequality. All right, now we have a compound inequality. This is one where I have two inequality signs in the inequality. Okay, when I solve a compound inequality, whatever we do to one side, we have to do to all three sides. Now before with an equation, whatever I did to one side, I did to both sides. But now instead of having two sides of an equation, I have three sides of an equation. One thing that it took me a while to realize was confusing to people is that you will always have your variables in the middle of your inequality. At least for this class and for Math 1010, you will always have your variables in the middle of the inequality. So you are looking to the middle to decide what to do. Don't look to either side to decide what to do. You're always trying to get the variable by itself. So if we have negative 6 is less than or equal to 4a minus 2 is less than or equal to 12, look at the middle and we want to get a by itself. So the first thing we would do is we'd say, okay, we have 4a minus 2. We want to add 2. But if I add 2 to the middle, I have to add 2 to the sides as well. Whatever I do to the middle, I have to do to both sides. So if I add 2 to all three sides, I end up with negative 4 is less than or equal to 4a is less than or equal to 14. Now some people, and I'm not sure why, want to get rid of that negative 4 and they want to add 4, but you can't do that. Only look at the middle and decide how to get that variable by itself. That's really important. So I look at 4a, I want a by itself, so that tells me I need to divide by 4. But if I divide the middle by 4, I also have to divide the sides by 4. So on the left I have negative 1, in the middle I have a, and then on the right I have 14 divided by 4, which is 7/2. So I'm done because my variable is by itself. Now I want to graph this. So the first number I put on the number line is a negative 1. At negative 1, I'll either put a closed circle or a square bracket. And the next number I'll put on the number line is 7/2, which is 3.5. And again, I will either put a closed circle or a square bracket. And I shade in the middle. And the set builder notation is just what we'd expect. It's the set of all A, then that vertical bar that means such that. So the set of all A such that, and then the inequality that A has to meet. Okay, solve and write in interval notation. Do this one on your own, pause the video, and then come back. Okay, now that you've got it done, remember the thing where our goal is to get x by itself. We don't try to look at that negative 6 and get rid of it. We're only looking at the middle and trying to get the variable by itself. So the thing I want to do is divide the middle by 3. But if I divide the middle by 3, I have to divide all three sides by 3. So I end up with negative 2 is less than or equal to x is less than 4. So we're done. We just have to decide how to write our answer. So we go back and look at the instructions and it says solve and write in interval notation. For some people it's easier to write interval notation if you've graphed first. You're always welcome to write it in all three ways to cover your bases. But if we just want to go straight to interval notation, remember interval notation doesn't have any variables in it. The numbers would be negative 2 and 4 because negative 2 is the very first, the solution to the very furthest on the left. 4 is the solution to the very furthest on the right. Then 2 gets a square bracket and 4 gets a round parenthesis. Okay, here's our second example of solving a compound inequality, and I'd like you to go ahead and do this one on your own. Okay, now that you're done, remember we're looking to the middle. We want the middle, in the middle we want that variable to be by itself. So the first thing that the middle tells me to do is to subtract 1 from the middle and therefore from every single side. So I get negative 6 is less than negative 2x is less than or equal to 2. Okay, so far so good. I've gotten rid of the 1. Now to get the variable by itself, to get x by itself, I just need to divide by negative 2. If I divide by negative 2 in the middle, I have to divide by negative 2 everywhere. Negative 6 divided by negative 2 is 3. In the middle, negative 2x divided by negative 2 is x. And on the right, 2 divided by negative 2 is negative 1. And remember, I need to switch my inequality signs. Okay, to write in set builder notation, I'm just going to put curly brackets, the set of all x such that, and then I drop my inequality in there. Now I have changed the way it's written. I want you to notice two things. First of all, you don't need to change the way it's written. I could have put 3 greater than x is greater than or equal to negative 1. It would have been fine. But it's not standard. When we have a compound inequality, we usually list the least number first. Now it looks like I've switched the signs. I haven't really changed the signs, but if I change the order in which I write that inequality, I'm just doing a mirror image. It doesn't really change the inequality at all. If you read the inequality that says 3 greater than x is greater than or equal to -1, read that same inequality backwards starting with -1. It says -1 is less than or equal to x, because I'm going the opposite direction, and x is less than 3. So that is my set builder. Okay, last example. Solve and write in interval notation. First thing I want to do is expand my parentheses. So I just distribute that 3. Then I combine like terms. Okay, so far so good. Now I need variables on one side, numbers on the other. It does not matter which one I do first. This time I think I'll just subtract 2x from both sides. And look what happened. All my variables are gone. What does it mean if all my variables are gone and I'm in the middle of solving? Okay, if all my variables are gone, I'm in the middle of solving, then that means that's either no solution or all real numbers. How do I know which one? Okay, if all my variables cancel, I'm in the middle of solving, I look and I see if what's remaining is true or false. Well, -4, that is less than -3. That's true. So all variables canceled while I was solving. What was left was true, so that means my equation's an identity. My answer is all real numbers. So that is the answer. The answer is all real numbers. Let's see how we could write it. If we wanted to graph all real numbers, it's just the whole number line. If we want to write it in interval notation, it's just from -infinity up to infinity. If I wanted to write it in set notation, it's the set of all x such that x is a real number, or x is an element of the real numbers. That is our last inequality example.